On December 5, 1945, 5 Avenger torpedo bombers took off from Florida for a routine training mission. 2 hours later, the flight leader radioed the base to report that his compasses had failed. By 7 p.m., all 5 planes and their 14 crewmen had disappeared. Search teams found no wreckage, no oil slicks, and no bodies. To make the situation worse, a Martin Mariner flying boat dispatched to rescue them also vanished. 27 men were gone in a single evening. Without physical evidence, public imagination filled the void with theories of alien abductions, interdimensional portals, and the lost city of Atlantis. For decades, these legends overshadowed the environmental data. In 2013, the World Wildlife Fund conducted a study to track decades of shipping accidents across every ocean on Earth. This chart displays the actual top 10 most dangerous waters for global maritime traffic. When adjusting for the massive volume of ships and planes crossing between Miami, Bermuda, and Puerto Rico, the accident rate in the region is statistically normal. Insurance companies, who monitor risk with extreme precision, do not charge higher premiums for vessels passing through these coordinates. Because the volume of accidents is typical for a busy shipping lane, the scientific investigation focuses on the specific environmental mechanics that explain why certain vessels in this region disappear without leaving a trace. Centuries of reports describe compass needles spinning wildly and sailors losing their bearings, which built the reputation of the area as a place of supernatural energy. This globe maps Earth's magnetic field, highlighting the South Atlantic magnetic anomaly. Deep inside, shifting molten iron creates a drifting gap in our magnetic shielding. Inside this zone, satellites glitch, and analog compasses give false readings. Flight 19 flew directly into this navigation scrambling anomaly. Losing orientation is the first step in a lethal chain of events. It explains how healthy aircraft can be lost, even when the surrounding weather appears clear. In 2016, meteorologists identified hexagonal cloud formations over the region. These clouds are the signatures of microbursts, intense, concentrated downdrafts of heavy, cold air. These localized air bombs hurl winds downward at speeds up to 170 kilometers per hour. A plane caught in this descending column loses lift instantly, leaving the pilot no time to recover before hitting the water. The combination of magnetic blind spots and atmospheric microbursts creates a predictable hazard. Pilots lose their sense of direction and are subsequently driven into the sea by downward winds they cannot see. On the surface, the rapid sinking of cargo ships was historically blamed on giant sea monsters. The Gulf Stream moves through this region with immense force. When this current collides with multi-directional storm systems, the energy of the water is forced upward. This creates rogue waves, solitary 30-meter walls of water that emerge and dissipate in minutes. These waves can snap a hull or flip a ship instantly. By the time rescuers arrive, the sea has returned to its calm state, leaving no evidence of the impact. Even in a wreck, floating debris like life jackets or oil should remain. The total absence of wreckage in certain incidents suggested to many that vessels were being pulled into other dimensions. The mechanism that removes the debris is located in the sediment. The seafloor here holds massive deposits of methane gas hydrates, pressurized, frozen methane trapped in the seabed. Temperature shifts can cause these ice structures to melt. The pressurized gas expands rapidly, bursting toward the surface in a massive column of bubbles. As the gas reaches the surface, the water's density drops sharply. A ship positioned above the eruption loses buoyancy and sinks immediately. The resulting suction pulls debris and life rafts down with the hull, leaving nothing on the surface. Explosive methane releases and extreme fluid dynamics work together to sink massive vessels and scrub the area of evidence before search teams can arrive. The Bermuda Triangle is a geographic intersection point where magnetic anomalies, the Gulf Stream, microbursts, and volatile gas deposits overlap. While sailors focus on the surface, geologists utilize the region's unique seabed as a high-resolution archive. In 2019, an international team drilled into the seafloor near Bermuda to extract sediment cores to map Earth's climate history. These cores show that 56 million years ago, a massive destabilization of underwater methane hydrates triggered an extreme warming event. Global temperatures spiked by up to 8 degrees in a remarkably short period. These frozen reserves remain on the Atlantic floor. As ocean temperatures rise, heat reaches deeper into the sediment, threatening to destabilize these gas pockets once again. The Bermuda Triangle serves as a natural laboratory for observing these global forces. The massive methane deposits documented here are a latent geological mechanism that directly informs our understanding of global climate stability.